And I'd just like to welcome everyone to the 3M Thermally Conductive Tape Seminar presented by Mel Foster. This seminar is scheduled for 30 minutes and all participants are muted, but please feel free to ask any questions in the Teams chat box. And Joe will be monitoring that and we'll be answering questions during the presentation or at the end if appropriate. And then we can also reach out to those individuals that may have more in-depth questions. Now I'd like to turn things over to our presenters from 3M, Paige Wera and Joe Petrie.
Thank you for the introduction, and we're happy to be here today. My name is Paige Wera. I am the U.S. Activation Marketer for the Electronics Materials Solutions Division. I've been with this division for a couple years now, been with 3M for about 6 years, and been working with Joe doing these types of trainings and getting people excited for 3M thermally conductive tape.
And thanks for joining, everybody. Joe Petrie. I'm the product application support, working with the Mel Foster team, EAS sales, TMC, in the upper Midwest part of the United States. We're really happy to have them working closely with the 3M Electronic Materials Solutions Division, working on your design challenges and bringing solutions to the next generation technology that you work on.
Thanks, Joe. So a little bit about what we're going to be talking today about. So we're going to start with some different trends that are happening, and that's really what's driving these thermal management solutions. Then we're going to talk about thermal interface materials. What are they? How do they work? We'll discuss some of the key market segments and different applications that are in there. We'll talk about some of our go-tos. And then also we're going to do a live demo showing you some of our go-to products and really what's the difference between these and any other thermally conductive tape and what's special about it. And then we've got a couple examples on applications just to show you real world scenario of where these have been used and why. Again, feel free to put something in the chat if you have a question or a comment, and we'll also have some time at the end. We don't expect us to be chatting for anything over 20 minutes, so we'll have plenty of time. And with that, I'll just kind of get going here. Actually, 1 minute or 1 second before we dive in, just to show you that we're going to be talking about the thermally conductive tapes from 3M today, but we have a variety of solutions that Mel Foster is your go-to for. So if you not only handle
you may
go
have
ahead, Joe.
You may have other projects in other areas,
Yep.
or other members of your team working in other areas, such as EMI, electromagnetic interference problems. We have a line of products that help for grounding and shielding to deal with EMI and providing solutions. There are some high temperature masking tape for printed circuit board assembly. We have some compressible microcellular urethane foams that are good for vibration damping, sound damping, and then bump on materials that keep your computer from sliding around on the desk, and some other special types of bonding tapes called thermal bonding films or anisotropic conductive films. So today we're going to focus on thermal solutions, which as electronics continue to get smaller and more powerful, the need for thermal solutions continues to increase. So Paige, start us off, please.
Yeah, thanks, Joe. That goes into right what I was going to say. So talking about some of those challenges, with one of them being microelectronics, everything is getting thinner and smaller, and that makes it a little bit more difficult to dissipate heat. Where's that heat going to go, especially when there's less room to dissipate it? So that's where an engineer will use thermal interface materials. Two other kind of trends in technology that are causing some more design challenges are our devices. We are consuming more data than ever. So that means that they need to have greater functionality because they got to meet those power and data requirements. And anytime that you're going to increase an operating frequency for a device, it's going to dissipate more power as heat, and that heat has to be dissipated or it's going to affect the device. Most of us also have a lot of connected devices. So those are going to have higher performance requirements, and they're going to end up creating that excess heat that has to be dissipated. So most of our devices, like, used to just have an alarm clock. You used to have a calculator. Now we have everything in one. So with doing everything, they're going to create more heat. So that's a design challenge that engineers across multiple market segments need to think about. And here's just that example here too of just different market segments that are having some thermal management issues. And we really do work with 3 key market segments. So, like, for general electronics, we do a lot with LEDs, communication infrastructure, appliance, and industrial. I'd say our top applications are going to be for LED lighting because they're getting much larger, they're more powerful, they're going to need some heat dissipation. Same with batteries, sensors, and really any device with a display. For our automotive applications, we're going to cover, EV and gas vehicles, ranging from displays and sensors to power electronics, kind of like that general electronics area. So in addition to those, we're really seeing anything related to EV or autonomous vehicle related, because those parts are having to do more things. They're having to do more functions. So they're going to be creating more heat. And also, as Joe has put before so eloquently, is that cars are turning into these rolling computers. So they've got those greater performance requirements, higher operating frequencies, and heat dissipation is really starting to be a hot topic in the auto world.
Yep.
And then many of our applications in aerospace and defense, they're going to be focused on avionics in the cockpit, or sensors and displays throughout the aircraft or drone. I'd say that the top applications do tend to be in the cockpit. I mean, if you look at the picture, you can see all the flight instruments, the control board, each one is generating heat. So similar to what's happening in a vehicle cockpit, airplanes, they've replaced many of their meters, their analog equipment, and now they're having these advanced electronic systems, and they're all in very close quarters, and they're producing heat. So that's where an engineer will say, what can I use? Well, 3M offers thermal interface materials. And thermal interface materials are also called TIMs for short. They're inserted between the heat producing device and the cooling device to help dissipate the heat. Some of the really key pieces of having a TIM is it's got to be form fitting, and I'll show you that in a demo here soon. Making sure that it's form fitting, it's having good wet out ability. That means it's going to completely fill air gaps, and you want to do that because air is a poor conductor of heat. It reduces the thermal performance, and it makes it harder for the TIM to do its job and dissipate that heat. For any engineers on the call, you're probably very familiar with thermal conductivity. Our thermal interface materials, they're thermally conductive, so that does mean that they can conduct or move heat. The more heat that is generated by a component, the higher the thermal conductivity, or K value, the thermal interface material needs to be, effectively transferring heat to a cooling device.
And
Today,
Paige,
go ahead, Joe.
what's interesting in there for adhesion, and then there's other similar requirements for adhesion in the automotive market. And as such, these customers and design engineers come to 3M because of our reputation for having high adhesion, bonding strength, high shear, high temperature performance, low temperature performance. And yet these tapes do that and more, and they are thermally conductive. So this is our overall portfolio. Where folks are coming to us for these types of bonding and joining solutions, bonding that heat sink to an integrated circuit or the heat source, or an LED light to something that's working as a heat dissipation layer or channel. So it's our adhesive technology that we have based this portfolio on to deliver these solutions to these customers.
Yeah, well put, Joe. These are intelligent tapes, right? They do bonding because they have that great kind of formulation from 3M's adhesives, but then they do a little bit more. So they're also dissipating heat. So now we're here to the meat. So what does 3M have to offer for their thermally conductive tapes? You can see on here, we've got the tapes. They're sorted horizontally by thickness. They go from thinnest to thickest tape. The tapes are also sorted vertically, and that's by the thermal conductivity and the lowest to highest dielectric strength. And the black stars are products with thicknesses. They're on our go-to material list. That means that you can get them faster. They've got a low MOQ, short lead time. They've got samples available because we really want to make it as easy as possible for you to find the right material, prototype it, and then when you're ready to ramp up, get that order in. So we're going to focus talking about the go-to materials. So that'll be the 8926 series at the top, and then the 8805 or 8800 series that's right below it. So I'm actually going to turn my camera back on, and I'm going to do a little demo for you.
Paige, while you're doing that and pulling that together, a question came up about our heat transfer coefficients of these materials. And this chart is actually pretty good, and we'll turn it back on in a minute there. But the 88 series, 8805, 8810, 8815, 8820, it has got very high adhesion for, and you'll see in this demo in a minute why it has such good adhesion. But the thermal conductivity is about 0.6 watts per meter Kelvin. There is another version that Paige is going to show you in a second called 8926. And in a thermally conductive tape that provides adhesion, not just gap filling, but high adhesion, that has a 1.5 watt per meter Kelvin thermal conductivity tested to that ASTM D5470. This tape right here, it's got this blue liner on one side, and you can see Paige removing it. This is an example of our 8810 thermal tape. Go ahead, Paige.
Yep, so that means 10 mil thickness. What's really unique about this is it's got some viscoelastic properties. So you see how I can pull it and it goes back. That's good for when you're going to be having an application that's on, something that's moving. So like automotive, aerospace, that's where it's going to be really important. And then also it's that
coefficient of thermal expansion also between different substrates, but its ability to absorb a little bit of that shock and vibration and CTE is actually a great benefit for this tape. Go ahead.
Definitely. And it's also very conformable, as you can see. I mean, and this is an LSE substrate, so it's good for bonding to that as well. We think of these little dimples as, things that collect air pockets if you don't have something that is conformable. So you want this tape to conform, and that's why you can see the dimples throughout. Because that means you're going to get that full 0.6 K value. So when I peel this off, it's hard to see with this glare here, but you can see the little points or the little kind of dimples that were on here. And that means that it's filling those gaps, it's wetting out, and it makes it so it's more conformable to it, and it's going to have better heat transfer. So now a different tape that we have that is also a go-to product is 8926. This has a 1.5 watts per meter Kelvin, so a little bit higher than the 8800 series. And then what's also a little different about it from the 8800 is that it doesn't have that viscoelasticity. So what this is really popular for is like LED lighting applications where they're just so hot and they're larger now. They need to dissipate that heat. So they'll use something like the 8926 to be able to dissipate a higher amount of heat. So again, it's, as you can see, it's conformable, right? It's having this kind of nice wettability for it. It's not as conformable as the 8800 series, but this one also has a 20 mil thickness I'm showing you. So that's a little bit different. And then when I do this kind of test here, you can see the dimples a little bit better, showing that wet out and the full heat transfer.
Yeah. So that's good. Hey, these thermal tapes have been tested to the UL 746 C, which is an environmental enclosure testing, where it sees thermal and humidity cycling. And these actually perform quite well in some of these high humid and more difficult environments that a LED light or some sort of system could find itself having to function in. Go ahead.
Yeah, absolutely, Joe. And you can see on here, I remember you were talking about it, how we have the conductivity. So that you can see the 1.5, 0.6, 0.6, and then kind of the rest are 0.6. This one's a little bit different. This is our heat spreading tape, 9876. Comes in, I believe, a 10 mil and a 15 mil. And this is where you need to spread the heat. And then when you spread the heat, that's going to kind of help dissipate it a little bit, besides having it in one spot, where sometimes electronics can have hot spots. And then once you kind of spread it, then it'll be dissipated in another location.
Like over a larger surface area. So the top products then are double-sided tapes that are used for bonding and joining. And we have them in these different configurations, but the go-to materials are 8926 and that 8805, 8810 series. 8926 carries a UL94 V0 rating for flammability. The 88 series has got excellent adhesion on difficult surfaces within environments requiring coefficient of thermal expansion in a constant bond and join. The 98, 82, 85, and 98, 90 is a traditional transfer tape. And what we're finding as products are being hand assembled in these types of applications, they'll lean more toward our 8926. And we didn't put a demo together today on this 9876, but this is a heat spreader. You may have applications where you don't have the space or luxury of a heat sink, but you've still got to get heat, and you've got to get the heat away and dissipate it in some manner. And so the 9876 is a copper tape, thermally conductive adhesives that take the heat from the hot spot, such as a DDR3 memory card, and move it away from the heat source so that it can operate within its designed temperature parameters.
Yeah, absolutely. Thanks for those descriptions, Joe. And we actually got an example too. I talked a little bit about the LED lighting, but here's one that we've had for a customer. This is what was LED lighting in a grow house. So, this one happened to be for agriculture, but we do have some for, industrial or automotive. This picture shows a small LED, but we have done LEDs that are very large, and those ones get extremely hot. So for small LED, 8810 might be sufficient with its 0.6 thermal conductivity value, and a larger LED would use the 8926 with a K value of 1.5, or even a thermal pad if there was a gap. And typically our tapes are going to be used to bond the heat sink to the LED. And why this is kind of important overall is that, it can be the difference between, crops that are healthy or crops that are dying. If it's getting too hot and the light's burning out, and then that area, those crops are not going to get what they need to be able to grow. So this is a really big area that we're seeing a lot of growth in right now.
And this also is a good indication of the adhesive performance that these applications require. This environment will be humid. This environment will have splashes of water or other things are going on. And design teams have relied upon a 3M adhesive technology on these thermal tapes, such as 8926, for these types of demanding applications.
Yeah, absolutely. And we actually have another example here for appliance displays. So for, kind of a technical standpoint, I think of like a display is a display. So this could also be applicable outside of just an appliance display. So, whether it's a touch screen like this fridge, or, a smaller and more basic screen, or kind of a ruggedized outside display, there's going to be a PCB. Going to be generating heat, and that heat has to go somewhere. So we say to, start with those go-to products, either be the 8926 or the 8810, depending on, what the kind of application requirements are, and how much heat is being created. Usually they'll have they'll tell you the thermal conductivity, so then you know what to choose. But we're seeing a lot more with appliance, or I guess any type of display as well. And then I did say it would be about 20 minutes max, and I was not wrong there, making sure we can make the most use of your time. So
Yeah.
I
Because we
believe.
we wanted to,
Go
and
ahead.
we wanted to focus on these thermal interface solutions. Again, the thermal tapes are bonding and joining where you won't necessarily need some sort of mechanical fastener to attach the heat sink together. People rely on the tape's adhesion for their assembly. But we made reference very quickly to our thermally conductive epoxies. We have two different versions. One of them is electrically insulating, and the other one utilizes a aluminum filler. And we do quite well in a variety of potting applications where the heat dissipation is required, as well as being electrically insulating. And then there's some traditional thermal pastes. They call them pastes or grease, and we've got one with about 5 watts per meter Kelvin thermal performance. So overall, pretty good size number of products in portfolio to address thermal management applications.
Yep, and I think, is that poll up now?
It is now, and we are getting responses. Thank you to everybody who's responding. I would like to also thank Paige and Joe for taking the time. This was an excellent presentation, and to all the participants for taking the time out of their day to participate with us. We will be providing the recording link in the next 24 hours, but please feel free to reach out to your Mel Foster field sales representative if you'd like to discuss this topic further.
And we do have time for additional questions if anyone has any right now.
Sure.
Okay, we do have one. How does the tape hold up to weather environment, sunlight, UV, wide swings in humidity? Joe,
Yeah,
do you know that?
the wide swings in humidity, it absolutely has been tested to that UL 746, which was up to 95% humidity, I believe at 100 degrees Fahrenheit and I'm not trying to remember the test method off the top of my head, but it was for days on end. And so the 8810 works well in those very high humidity environments, as well as dry and cold down to -40. All of the products that 3M develops in this space are a -40. And then the tapes themselves, based on how we actually make them, will have anywhere from 105C to about 120C on the top end as a continuous heat exposure um, uh, properties. Okay. Most of the electronics might be 70 to 90C, but our tapes are designed to operate at those above 100C continuous.
Thanks, Joe. And Joe Petrie just put in his number as well in case there's any other questions that maybe you have individually too.
Yeah, the sunlight and UV, these tapes are typically inside and or between things. So they're not seeing a lot of direct exposure for UV light, but they're definitely seeing weather type conditions in these LED light bar type applications. I have a testimony from one of our customers who makes LED lights, and it was nice that he said that in the 10 years I've used your product, I've never had an adhesive failure, but I've had failures with some of my components that are on my lights. So thank you for making a great tape. And so we hope to thank each one of you for evaluating these tapes and helping us work with you and solving your next design challenge.
Absolutely. Well put, Joe. Thank you, everyone, for attending. I hope you learned something new, and you can help understand more of what we do and if we can help with your design. So appreciate everyone attending today, and hopefully we'll talk soon. Thank you.
Thanks,
Thank
Mel
you all for your
Foster.
time. Take care.
Bye, everyone.
Bye.